Okay, so first we have to make an equation for g of x. So we know that g of x equals 80 plus the integral 1 to x ft dt. And with this equation, with the graph, we can make a sign chart for g prime, which equals f. And so the critical points that we're gonna put in are -9, -4, 1, 3, and 10. And so there you can see. And so from -9 to -4, the g prime is positive. From -4 to 1, g prime is negative. From 1 to 3, it's positive, and from 3 to 10, it is negative. So we know it's going to look a bit like that. Okay. And now we can also make so here we know we can answer the first part of the question, and we know that g of x is decreasing over the intervals -4 to 1 and 3 to 10, because g prime is negative on these intervals. Okay, now we can go ahead and make our second sign chart. And here we will find for the critical points here, we have to put in all the points where the slope changes, because this is a sign chart of g double prime, which is equal to f prime. Okay. So we see here that it'll be -9, -4, -3, 1, 2, 3, and then 7. So -9 to -4, -4 to -4 to -3, also negative. Then it switches, and now -3 to 1 here, it's positive. 1 to 2 is also positive. Then it flips again. 2 to 3 is negative. 3 to 7 is also negative. And then 7 on, it's just 0. So I'm just not going to write anything for that. And so now we can answer the second question, which is where is it concave up? And the g is going to be concave up wherever the second derivative is positive. So we see here that the second derivative is positive over -3 to 2. So we can go ahead here and write g of x is concave up over the interval -3 to 2, because its second derivative, g double prime, is positive on that interval. Cool. Now we have to go to the final part of the question, which is find the absolute minimum and absolute maximum. Okay, so for this, we need to make a table of all of our critical points and actually find what the values are. Because as we see here, we we know where the relative max are going to occur, so now we got to find out which ones are going to be absolute and which ones are just going to be relative. So -9, -4, 1, 3, and 10, those are our critical points. And now we just plug them in to this equation up here. So -9, and I'm just gonna go ahead and fill in the areas over here. So -9, 4, 5 times 2. This is 5. This is -5. Pi r squared, 2 squared. This is 2 pi. Now we'll block this off. 4 times -9 is -36 divided by 2, -18. And then 3 times -9 is -27. All right, cool. So at -9, we have 80 plus, from 1 to -9, 0, 80 plus 0. So -9 is 80. At -4, from 1 to -4, that's -5. 80 plus -5 is 75. Okay. Now at 1, it's just going to be 0, so 80 plus 0 is 80. And then 1 to 3 is 80 plus 2 pi. And then 1 to 10 is going to be 80 plus 2 pi, and then minus 18. I'm writing this down here. Minus 18 minus 27. Minus 27. Okay, so that's 10. All right, so 80 minus 18 minus 27. So we end up with 35 plus 2 pi. Okay. So, we know now that, so this was going to be a min. This was going to be a max, min, max, min. Now we just gotta find out which ones are absolute. Okay. So these are gonna be relative. Oh wait. Yep, those are gonna be relative. So the absolute min is going to occur at 10. Yeah, it's going to occur at 10. All right. So there is an absolute maximum at x equals 10 because 10, absolute minimum, oopsie, absolute minimum at x equals 10 because 10 is a right endpoint.
Matthew?
I'm doing a quiz.
Matthew?
Yeah.
Road key?
Oops. Okay, as I was saying, because 10 is a right endpoint, and the function decreases on the interval to 10. or 3 to 10. 3 to 10. Cool. And then now for that absolute maximum. So we know this is gonna be relative. So this is gonna be absolute maximum at 3 because it's the biggest value. So there is an absolute maximum at x equals 3 because the function changes from positive to negative at x equals 3. X equals 3. And as you can see in the table, that is the biggest number there. So that is my answer. Cool. Small correction. At -4, the y value is actually 85. I just forgot to flip it when I was going backwards. So it should be 80 plus 5. So yeah, but yeah, that's all.